Tell us a little bit about what was the level of detail people were happy with back then, and what is the level of detail that is today, sort of the vogue in a typical industry situation.
Great question. We have come a long way. So, when you think about using computers to solve real world problems, you have to have three things. One, you take that complicated problem. The only way to use a computer, or one of the ways these days to use the computer, is to look at the problem and turn it into some governing principles and equations. And then you take and dissect that problem into discretization. That's what we call it.
Mhm.
We divide, put a grid, and develop a numerical method. You come up with a strategy to use zeros and ones of the computers to solve your problem. Okay, that's the second. So hardware, then you have numerical methodology, and then you also have the hardware, which is you have to take it to your laptop or your local cluster or some national cluster, and you will solve it. Let's think about what has happened to all three of these things. Okay, let's start with the last one, which is computers. Now, can you believe it? From 1980s to 2025, the power of the biggest computers have increased 1 billion times. Now, everybody may not have access to the world's biggest computers, but the same trend is true in the sense that the desktop that you have on your desk is many, many times more powerful than what it used to be. In the same way, numerical methods, lots and lots of multi-grid methods. In old time, there were some very classical methods which weren't that efficient. But over years, CFD people have developed a lot of numerical techniques to solve the governing equations. Okay. And the last thing also is what we have done, the community has done a wonderful job in identifying what equations to solve. That's
Hmm.
something that you can't forget. We did talk about how the underlying problem, whether it's a diaper design or a rocket design or an engine design, but there are subtle nuances. Okay, you have to have some intelligence reductions or simplifications that you do, and you develop some better equations that you can later take to a numerical methods and to your computer. So all of them have seen tremendous progress over the years. So we now can do study problems and do simulations far more detailed. And once upon a time, it used to be sort of like playing a guidance role. You do a simulation, but we aren't ready to do full design without any experiments. Okay, but even now, I tell you, there are challenges. Okay, industry will use CFD in a great way to reduce the number of experiments they have to run from maybe several thousands to just one or two. That's a big cost saving, but still people will have to do some experiments to validate that the simulations give you the right answer. But we have come a long way in the last 4 or 5 decades.